My students have just gotten finished with a quick study of some measures of center like mean, median, and mode. And now we're looking at measures of variation, measures of variability. And the two measures that we're going to be looking at are interquartile range, which is often referred to as IQR, and we're going to get mad. We're going to use the mean absolute deviation to help us with a measure of variation. Now, our math program has some examples that go along with showing students how to do this work, but I like the team talk better. I like the examples here because they're like the type of the work students are going to be doing. So instead of doing the teacher think aloud that comes along with our math program, I thought I would just demonstrate how to do a couple items from our team talk sheet, and then I'll turn the students loose. The first thing that you would want to do is look at your situation. Now, number 2 says, Joseph's phone bill shows how many calls he made during a 2-week period. Here is the list of his calls. And we've got a pretty good long list of data there. And I'm going to assume that there are 14 values in that list because there are 14 days in 2 weeks. Part A wants to know which measure of center, the mean or median, is best for this data. And then B, what does the measure of variation tell you about the data? So let's look at our data and try to figure out. Now, one of the things that I want to point out, if you have an outlier, a really big outlier in that set of data that's really going to skew your data, you'll want to go with median. If your values are pretty much consistent, it would kind of look close together, not a lot of not a big wide variation, then you'll want to go with mean. And when I look at these data points, I see that the lowest value is 78, and it goes up to 98. There's like 1, 2, 3 values in the upper 70s, and then the bulk of them are in the 80s, and then you have some of them that are in the 90s. This looks to me like it's kind of a compact set of data. I mean, we're not going to have, we don't really have any outliers here. And because of that, I think that the mean would perhaps be one of the best ways to look at this data as far as figuring out what measure of center we want to use. So I would focus on the mean. Now, when you find the mean of a set of data, you would add the values together and then divide the sum by the number of values in your set. Now, that's kind of like what you do when you find the mean absolute deviation, but you want to see how far each value deviates from the mean. You want to see how far away it is from the mean, and you're going to have to use absolute values to help you figure that out. So for part A, I would say my measure of center that's best for this data is mean, and B, because we are using mean as our measure of center, for our measure of variation, we want to use mean absolute deviation. Now, had we chosen median, we would have wanted to have used the interquartile range. But since we're using mean as our measure of center, our measure of variation is going to be mean absolute deviation. And I'm going to show you all how to do this. I'm going to show you step by step how to do it. It's going to be important for you all to pay close attention and work it out with me. So as I monitor how you all are doing, I'm going to be looking to see, are you putting in the same things that Mr. Hall's doing? Because if you're not, when you get turned loose to do this in a moment, you're going to be a weak link for your group. Okay. Active listeners, let's get ready. I'm going to use my calculator a lot. But the first thing that I'm going to do is I'm going to find the mean of the set of data, and then you'll see what we'll do next. So I'm going to find the mean first, because I need that to find my mean absolute deviation. And I am going to use the calculator to do this. This is going to be a calculator task. Now, one of the things I really like about these TI-15s is it's got that window, and it's going to allow me to plug in my values, and as I plug them in, I can look and see if I make an error. And if I make an error, all I have to do is correct it with this little backspace arrow, the little deletion key. So you want to be sure that you watch as you work these out. Everybody needs to get their calculators out of their tubs. I'll be math toolkit, I guess. And let's go ahead and start plugging them in. So, I'm going to go ahead and plug in 79, 84, 98, 88, 94, 79, 89, 87, 86, now 78, 97, 78, 98, and one more 98. And then I hit enter, and it gave me 1,233. Okay, does this mesh with what you got, children?
Yeah.
Okay. Now, while some of you are catching up, I'm going to go ahead and count the values in my set of data. I know there's 14, but I want to double check while you all catch up with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sure enough, there are 14. So now, I'm going to say divide by 14, and my mean is 88.0714287, and it probably keeps going and going and going. Now, what I'm going to do, since 0.0714 is such a small amount when I look at the overall set of data, I'm just going to round to 88. I'm just going to leave my mean absolute, I'm sorry, I'm just going to leave my mean as 88. I'm just going to do it that way. So, I'm going to say then that for my mean is 88. Now, I'm just going to make a little note of that. Now, I'm going to show how to find mean absolute deviation. The first thing I'm going to do on my paper is I'm going to list all my values from my data set. And I'm going to just go ahead and do it right here. And let's see, I've got 79, 84, 98, 88, 94, 79, 89, 87, 86, 78, 97, 78, 98, and 98. So I have all my values. Now I want to point something out to you, children. I wrote mine kind of like this because I want to make sure I can get all the data on the Mondo pad. And if I wrote each one on its own line, it would be so small you wouldn't be able to make sense of it. So I'm going to leave my pad so I have all 14 of my values, and here's where the mean absolute, the mean absolute part comes in the deviation. I'm going to put subtract 88 right here. Now, if I said 79 subtract 88, I'm going to wind up with negative 11. True or false?
True.
Negative 11, what? But see, we don't want any negatives. We want to know the absolute values of these. So, I'm going to put my absolute value brackets here. And so 79 subtract 88 is going to give me, oh, I misspoke. It wouldn't be 11, it would be 9. I can't believe I made such a simple error. So instead of negative 9, it's going to be positive 9. You see it? Now I'm going to wind up to find the absolute value of the data value, subtracting the mean, and then it's going to tell me about how it deviates. Alright, so here I go. This is kind of tedious. It takes a little bit. But it's okay. Bless you. Okay, so I went ahead and I found the absolute values there to see how far they deviate. Now, in a moment, I'm going to find the mean of those differences. I'm going to add up 9, 4, 10, 6, 9, so on, and then I'll divide that sum by 14, and it'll give me my mean absolute deviation. It'll tell me how far the individual values, how far they deviate from the mean. Something like that. Alright, so I'm going to go ahead and do that very quickly. Since these are small numbers, I think I can go ahead and do it. Just, alright, 13, 23, 29, 38, 39, 40, 50, 52, 61, 71, 81, 91. So I got 91 when I added all of those together. Now to find the mean absolute deviation, I have to divide 91 by 14. Okay. When I divided 91 by 14, it gave me 6.5, 6.5. So the mean absolute deviation is 6.5. Now, because that is a low mean absolute deviation, and when I say low, a mean absolute deviation of 0 would be all the values are equal to the mean. And 6.5 is kind of low relative to the mean absolute deviation of other sets of data that you're going to be working with today. So 6.5 is kind of low. So what that tells me is that on a pretty consistent basis, this feller is making between 78 and 98 calls a day. I mean, that's a lot of calls in a day. He must live on his phone, but because that mean absolute deviation is relatively low, 6.5 or 6.5, it makes sense to say that on a consistent basis, the person, I think it says his name was Joseph, is pretty much making between 78 and 98 phone calls. It just hit me. I was saying the fellow lived on his phone. If this is an example of a real world situation, maybe he is somebody who has to call people a lot as part of his job. I mean, as part of my job as being a teacher, I have to do a lot of communicating. Most of my communication takes the place of emails or text messages and things like that, or we get on Google Classroom making announcements and stuff. So I do a lot of communicating too. So maybe this guy has a job where he has to make a lot of phone calls.
Like an office worker or something?
Yeah, like maybe he works in an office, or maybe he works as a teleconference person. Maybe he does these, calls people up and asks them surveys, or if they want to buy stuff. Who
In a call
knows?
center?
Maybe at a call center. All right, so that's one example of a measure of variation, which is mean absolute deviation, and it's not that hard. It's got a lot of steps to it, but you all already know how to find means of a set of data. You already know how to do absolute values. You already know how to do this. It's just what steps do you do in what order. Now, I hope that this has helped you, and if I were to give a math practice on this, I use what I know about mean and median to make my first decision, which is to say I was going to focus on the mean of that data set. And then I use what I know about mean absolute deviation in order to find the mean absolute deviation in this set of data, and to come up with my conclusion that, yes, on a pretty consistent level, this feller is making between 78 and 98 calls a day. I hope that this has helped y'all.